Happy Pi Day, everyone. Let's talk about approximations of the number pi. As you know, pi is an irrational number. That means that pi is not a rational number, so this decimal expansion is non-repeating. So what we do to approximate pi is just use cutoffs or other numbers that are similar to pi. For example, because the expansion starts with 314, we approximate pi by 3.14, which is an okay approximation, and it just reminds us of the date March 14th, which is why in the US we celebrate Pi Day today. That's an okay approximation. The error in approximating pi by this number is 0.0015926, so it's not bad, but it's not very economical because what we actually did is use this number, 314 over 100, to approximate pi. But we can do better than that. If we're going to use a rational number to approximate, we can actually use a better approximation, which is 22 over 7, which is probably another approximation of pi that you are aware of. This was even known all the way back to Archimedes. So if you only use digits or numbers with one digit in the denominator, that's the best approximation you can use. So where do these approximations come from? These approximations that are the best approximations of pi come from what we call the continued fraction of pi. So 3 is an approximation of pi, and if you add up 3 plus 1/7, then you get that 22 over 7. And if you continue like that, you get other approximations of pi. Those approximations that you get from the continued fraction are called convergents. So 322 over 7 are the first convergence. The next convergence is 333 over 106, which is the best approximation with denominators up to 106. And the error now is pretty small. So what about the next approximation? So the next approximation is 355 divided by 113, which is an awesome approximation of pi. And the next one is 103,993 divided by 33,000 and change. And that one seems a little bit overkill. It's an awesome approximation, but your money is on this one. So if you really want a good approximation of pi, then use 355 divided by 113. That's a great approximation.